All right, so today I thought we'd move on to Java because we're going to be doing object-oriented programming next. But we're going to be doing object-oriented programming in the context of Java because Python's really not an object-oriented programming language. It has classes, yes, and we demonstrated that, and they are useful, but it doesn't have most of the stuff that's generally associated with object-oriented programming. It really doesn't have inheritance because it doesn't have strong typing. It has abstraction, but it doesn't have strong encapsulation. And the other one, let's see, and it doesn't have strong polymorphism either. Java has all of those things. So we're going to start talking about Java, but before we do that, we have to introduce the notion of how to create objects, because object-oriented programming, those are the four pillars. Abstraction, encapsulation, inheritance, and polymorphism, but underlying it all are objects. And so what I want to do is I want to repeat our book data processing exercise in Java, but I want to think about objects first. What we did before was we thought about tuples, and then as an afterthought we said, oh, okay, well, we can treat authors like tuples, or we can create an author class, or whatever, before we even open up a file. I want to think object-oriented programming first, which is a bottom-up approach. We're going to be thinking about the objects that we're going to design first, that form the building blocks, and then we're going to bring those things together until we've solved the problem. Only after you've created the objects can you make them interact with each other to produce something, right? So I'm going to start from scratch here. If you've been following along with the main section, this is all going to be old, who cares? But we are going to go on quick mode here. So let's go ahead and start from scratch here. I've got Eclipse here. If you've never installed Eclipse, you need to install Java. I recommend 21. That's the most current version. I would recommend installing the Java, the J2E Eclipse version. If you want to, you can go back to Lab 1, and it walks you through that process. Once you have it up and running, though, you need to create a new Java project. And I'm going to draw your attention to this thing down here, which will be on by default. This create module info, do not enable that. That will screw things up. All right. So let's just go ahead and create, I don't know, CSCE 156H Spring 2024. Obviously, if you're doing this for the project, you'd call it something else. Note here, I already did the project. Anybody read the project already? What's the company? Wireless. And so there's my project there, right there for the solution. Right? Or a solution, right? And so let's go ahead and finish this up. There we go. What are you complaining about? Probably the Java version. Build path, configure. Do you see that exclamation point there? It's complaining about something. So what are you complaining about? Sources. I don't see what you're complaining about. Libraries. Oh, the JRE. Okay. Remove. And let's go ahead and add. No, let's cancel this. Darn it. All right, let's go ahead and delete this and start over. Delete it on the disk, yes. All right, new. Apparently I don't have Java 21 installed. Fine. All right, I only have 17 installed. So CSCE 156H 2024. Yeah, spring 2024. I'll just name it that. And instead of Java 21, I'm going to have to downgrade. I know I have Java 17 installed. There we go. There. Now it's happy. All right. You just need to make sure that the correct version of Java is installed and that it can find it. Right. I've got a source folder here, and that's where I can start putting in packages. So remember that packages are your way of organizing code. UNL.soc. There's going to be a folder called UNL. Under that, there's going to be a folder called SOC. Why? Because it's organizational. UNL is a larger organization than the School of Computing. If I want 156.CSE 156H, I could do that if I wanted to. But it's just a way to organize your code. Once again, make sure that this is disabled. Do not create any info files. Right? That's the package manager system that they introduced in Java 12 or 13 or something. Right? Now that I've got a package, I can create classes. Here's just a really quick hello world class. I'm going to want a public static void main because all programs have to have a starting point. Right? So system.out.println hello world. Always do this as the first thing to make sure that it actually works and compiles and runs. So now I've got my hello world working great. Let's go back over here to the original demonstration. What do the books look like? Book.csv? Nope. Where's my book data? I know that I put it in the notes. There we go. There's what the book data looks like. I'm going to grab this and put it over here. One thing I did in today's, in this morning's class is I recommended that you, first of all, you're going to want a data folder to store a bunch of data. So let's go ahead and create that data folder. But I also want a file here. Generally what I do is I put a scratch.markdown or scratch.txt so that I can cut and paste things and keep them in this plain text file over here. This is not a source file. It's just a regular old text file, right? And then I can go back and forth. And why is it Scratch? Well, it's kind of like a scratch paper, right? You want to do some work on a piece of scratch paper, and then you transfer it over to your final stuff. So scratch.txt, right? That is what a book looks like. It's an ID, it's a title, it's a last name, first name, an ISBN, a rating, and a year. So you tell me, where should I start here? Again, if I am thinking objects first, what object should I create first? What did we do in Python? We did a class, right? What was the class called? Book. Okay, I like that. So let's go ahead and create a book class. Book. Do I call it book, lowercase b? No. In Java, all class names are upper camel cased, right? That is, the first letter of each word is uppercased, including the first one. Book. This class will have to match the file name as well, book.java and book. If you misspell it, 3 O's, right? Then it's a compiler error. It's got to match, okay? All right. Did I call it books? No. Books would be like a collection of books, like a list of books or a set of books or something like that. So it's one book. Well, what is a book? Here's my scratch. Let's bring it all over here. Right? It's going to be an ID. It's going to be a title. Last name, first name, I'm not sure about that yet. But it's going to be an ISBN, 13, rating, and year. Now, a note here about variable names. When we're no longer in the Python land, right? When in Rome, act as the Romans. When in Python, act like the Pythoners. When in Java, make sure that you're following the Java conventions. For example, if this were the last name, I would use lower camel casing, right? If this is the author last name, I would say lowercase a, uppercase L, uppercase N, right? That's the way to do it in Python, or in Java land, right? The question arises when you've got a acronym like this, ISBN, right? Well, strictly speaking, if I were to follow, if I were to do all caps like this, then that tells me that it is a constant. For example, math.py, right? It's all uppercase, PI, right? So it certainly is not a constant. But if I follow the lower camel casing convention, it would look something like this, ISBN. That's ugly, right? So rules are meant to be bent, or guidelines are meant to be, rules are meant to be broken, guidelines are meant to be bent, right? ISBN, let's bend the rules here, all lowercase. Just treat it as one word. The only other alternative is to type it out. International standard book number. Who wants to type that out? Right? ISBN, it's good enough, okay? We'll come back to these two here in a second. But an ID, an ISBN, and a year. Right? Now, you also need to provide the types here. Right? You didn't have to do this in Python. Python has weak dynamic typing. That you can go ahead and assign it a string value and it magically becomes a string. You can assign it an integer value and it magically becomes an integer. Here you need to specify. So an ID, what does that look like? What type? An integer? Okay, I'll buy that. A title, I don't even have to look at that. What is that? A string. And it is capital S, right? ISBN, technically I think that they are strings because you can have an extended ISBN with a hyphen in it or something like that. So I'm going to go ahead and leave that as a string. Right? What about rating? And that's goodness rating, not like PG or PG-13 or anything like that. Right? What does that look like to you? A double, okay. Double. What about year? That's a good question. 1960, 1959, 2023. What are all those things? Okay. What if I had more data though? What if I had a year, a month, and a date? Day of the month, right? At that point, I have a full date, right? I've got three things. When you've got more than one piece of data, what should that be yelling out to you, screaming out to you? Make a class. A date class, publish date. Right? Except that don't reinvent the wheel. There is a local date that is built into the standard Java library, right? In fact, it's in the time library, java.time.local date. On your first lab, if you did the Java version, we had you use a library called Joda datetime. And it's because the original Java, how it dealt with dates and times and stuff like that, it was terrible. They assumed a Gregorian calendar, right? Which is a terrible assumption. It was also extremely difficult to use. So some folks put together this library called Joda datetime, and everybody loved it so much that guess what? They simply just copied it and brought it in and made it part of standard Java, right? So there's this local date. Why? Because today is what? February 7th, 2024. Is that the date everywhere on the planet? Nope. Cross over the international date line and it's a completely different date. That's why we call it local date. These things are relative. Time is relative, right? So just saying a date doesn't make much sense. A date, where on earth are you talking about, right? That's why we have standards like this, right? You specify a date and a time, but then you also specify a Greenwich Mean Time offset to say, to give you an absolute time, right? I don't want to do that yet. We'll just go ahead and keep it simple for now. But that's what I would do if it was a date time. That's got me thinking about author last name and first name. That sounds like two pieces of data. What should that be? Maybe not screaming out to you, but quietly screaming out to you. A little bit quieter because there's only two pieces of data. What should that be screaming out to you? But a little bit quieter. Make a class. Right? Whispering it to you. Okay. All right. Person. Right. Why did I call it person? Why didn't I call it author? Yeah, it's not just for books. You could use a person class for customers. You could use a person class for students. You could use a person class for 50 different things, right? Okay, well, what is a person? A last name and a first name. Okay? If we just wanted to define our class like this, fine. There's no bells and whistles though, right? Whenever I define a class or a structure or whatever, I probably want to come up with a bunch of other ancillary functions, exactly like we did over here in Python. I didn't have just a book class. Where's my book class? Load books. There we go. I didn't just have a book class. What else did I have? A constructor to create books. I had a toString method because I wanted to print books out. I had this other one that I needed just for Python. I had a way of determining whether or not this author or this book was the same as that book, right? By looking at their author, or that this one comes before that one, or there's a hash code because I want to put them in a set and make sure that they're unique. I don't have to type anything, right? If you have this stuff, and I'll come back to this, but I want to make it private, right? I want to create a constructor, source, generate constructor using fields. Done. That's what a constructor looks like in Java, right? It is a method that does not have a return type. It's not void. It's not int. It's certainly not person, right? It is returning a person basically, but because it's a constructor, you don't need to specify the return type. Ignore that for now, right? Okay. Last name and takes a last name as a string, first name as a string, and assigns this .last name to that .last name. The equivalent in Python was self, right? Over here in Java, we're using this, okay? There's my constructor. What else do you want? A way to print them out? Okay. That's I could auto generate this, but it's going to look ugly. So generate toString method. There we go. There. It prints last name, first name, but I don't want it to look like that. I want it to look like last name, comma, first name, without all this other boilerplate crap, right? So auto-generated code will get you 90% there. Then you need to go and massage it and correct it a little bit, right? What else did we have over here in Python? A way to say that something was equal and a way to use it in hash-based data structures. Well, guess what? Generate equals in hash code. Right? Now, it's going to be kind of complicated, but that's good enough, right? There's this other hash function already, first name, last name, you take care of it for me. Two people are the same if they have the same first name and the same last name. That's good enough for the design of this object, but generally, how is a person distinguished? What kind of an ID would you do here? What are some options? If we're only talking about people at UNL, how are people at UNL uniquely identified? An NUID? Right? If we're talking about people in the United States, generally, what are we talking about? Social Security number, right? If we're talking about more generally, think about your project, right? There is this universally unique identifier, UUID, that is a cryptographically generated random number, such that if you generate one and generate a second one, the probability that you're going to generate this, that anybody in the world, in the history of mankind or the next 10,000 years, generates the same number is infinitesimally small, right? That's how it works. It's a universally unique identifier, right? That's how I would do it if I was a real system. I don't have that thing here, okay? If we were doing a database, though, private int, person ID, right? Eventually we'll do this because it's going to be tied to a database, and the database is going to generate that unique ID, right? In that case, I would say that two people are equivalent, not if they're the first name and last name, because they could have two John Smiths. John Smith, born in 1952, born in 2011, right? Two different John Smiths. How do I uniquely identify them? I let somebody else do that, right? But otherwise, there's more boilerplate. What else would you want? I've been able to determine if something is equal, something is hashable, so that I can put it into a list. What about this thing right here? Right? So those of you coming from 155H, do you remember how you made a person or an object comparable to another object? Implements, comparable. Right? And what are you going to compare it to on another person? Apples to apples, oranges to oranges, persons to persons. Should you be able to compare a person to a book? You can. You could write code to do that. It's really weird, right? How would you compare them? That title is equal to that person's first name? Nonsense, right? So make sure that you are comparing apples to apples. Right? Now let me go ahead and add an unimplemented method here. Right? It's been a while, but we did this, right? In 155H? Yes? No? Okay. Even if we didn't, then even if we didn't, I don't care. We're giving a review of it, right? So I want to compare this person to that person. Oops, sorry, that should be that person, right? This is a key word. That is a variable name. I want to compare this person to that person. How do we go about doing it? So one, compare the last name, right? If different, I'm done. Otherwise, if same last name, ... compare, well, what else? What's the only thing I have left? The first name, right? ... right? So how do I go about comparing strings? There's a last name this dot last name, and I want to compare it to that dot last name, right? This dot last name, how do you compare it to? Compare it to, dot compare to, right? There's this function that's built in, that dot last name. Do you remember the pattern there? It's the same pattern as Python. It's the same pattern as any programming language. It returns something negative, right? It returns something negative if this dot last name comes before that dot last name, right? It returns something positive if it's the opposite, right? And what's the only other possibility? 0 if this dot last name is equal to that dot last name, right? So let's capture that value into a result. Right? Now, if it's negative or if it's positive, right? If that means that they're different, they're done. You can just return it. Return result. Result. Right? Right? But what if they have the same last name? Right? So, if they have the same last name, then compare the first name. So, if result is equal to 0, that means that they have the same last name. What do I return now? This dot first name compared to that dot first name. There. And it gets returned down here. This is the pattern. This is my outline. Right? When you're doing programs, generally what you want to do is you want to whiteboard it. Outline it on a whiteboard. Take a picture of it. Transcribe it over here to code. Step 1, open the file. Step 2, process it line by line. Step 3, sub-step 3, do this, do that. Right? Outline it. When you're done with that outline, what do? Get rid of it. Clean up your code. There. Reformat it to make it look nice. Right? So once again, we will compare the last names, and there's the result. If the result is 0, then we need to break ties by going to the first name. In either case, whatever the result is, we return it. Okay? If it's still 0 down here, then we have John Smith and John Smith. There's nothing else I can do. That's the same person. There's only one John Smith there because I don't have some other universally unique identifier up here. Right? There. That gives me the less than. That gives me the total ordering there of all authors. Right? All right. Now go back to book. I don't need a last name, first name. Now what do I need? What's the scratch look like? The title, I need the last name and the first name of the author. But now that I've defined an author class, what do? Not an author class, but a person that is an author. I use it. Right? The author is a person. The person now has a first name and a last name, and all of the bells and whistles that I just implemented over here. Actually, that Eclipse did mostly for me. All right, that one's done. Oh, actually, is it done? All classes need documentation. Represents a person. Right? He doesn't have to get fancy. Right? What about functions? You know what that is by looking at it. It's a constructor. That doesn't require documentation, at least for this class. ToString. It does what it says. It converts it to a string. No documentation needed there. Hashcode equals compare to. Those are all self-explanatory. However, if you want to, you can give some more documentation. For example, compares people by last name, then by first name. Right? Because if I did it in a different order, first name, then last name, why you would want to do that or whatever, or by ID, then I would want to put that in the documentation. That would make this into a non-trivial function. But as it is, it's a pretty trivial function. No documentation needed. Now we're done with that class. Right? Do you remember over here I made everything private over in the person class? Why? Because that's strong encapsulation. If anybody tries to change the last name after it's been created, they won't be able to because they can't access that variable because it's private. Over here in Python, what could you do? You could do whatever you want. It's the Wild West. Why? Because you don't have strong encapsulation. We'll talk about it more formally later on, but encapsulation is 3 things. The grouping of data, right? And we have that over here, right? We're grouping IDs, titles, authors, etc. into one logical unit. We have that over here as well. We're grouping these 2 strings together. The second part is the grouping of functionality that acts on that data. We've got a toString method, hashcode equals, compare to. We have the same thing over here in Python. The third thing that Python doesn't have is the protection of data, private. We need to protect this data so that nobody can set it. Nobody can change it once we've created it. Right? So I'm going to follow the same pattern over here. I'm going to make everything into private. Right? If you want to go one step further, you can, and make it final. Do you remember what the final keyword does? Changes it into a constant, so that once you set it, not even the book class could reset it. Nobody can reset it, right? Regardless of whether or not it's private, right? I mean, you can go that far or not. I generally do, but you don't have to go that far, right? Okay. Once again, go through those steps. Generate a constructor using the fields. Done, right? Generate a toString method so that I can print books out. All right, that's a good start, but I don't care about that. I care about the title. Actually, I'm going to steal the, what does it look like over here? There, looks something like this. That's what we did over in Python. The title, concatenate by, concatenate a parenthesis, and then concatenate this dot year, then concatenate a comma. By the way, concatenation is the same in Java and Python. And then this dot rating, and then concatenate a parenthesis. Does that look like it? Oh, I don't have an author. This dot author. There we go. Title by author, then in parentheses maybe a space, and then the year, and then the rating. Right there. Right. Getting it to look nice can be, you know, was it Machiavelli that said, "Don't let perfect be the enemy of good." Right. At some point, you've got to say that's good enough and be done with it. Right. I need to get it to align just a little bit more, just a little bit more. As far as the grader is concerned, as long as it's readable and you are outputting as much information as the expected output, you're golden, right? If you want to get all fancy with ASCII art and whatever, go ahead, be my guest. But this is good enough. Here's another nice, more compact way of doing this, more Pythonic even. String result is equal to string.format. Format is printf style formatting. So if you wanted to, you could put %s for the title, by %s for the author, in the year, %d, comma, %f, and that's good enough. And then you can go this dot title, this dot author, this dot year, this dot rating. There. All right, which one, and then return the result. Return result. Which one of these is more readable? The first one where I have all the formatting in one string and then just a list of variables, or the second one where I'm doing plus, 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 plus. Which one's better? You decide, right? I think that one's better, but that's just me. Right? And you don't need to put this into a result. You can just say, return that. Now I've got it down to one line. Code golf, remember? Right? I can do that in 5 lines of code. I can do that in 3 lines of code. I can do that in 1 line of code. Right? All right. What else do we want? We did a constructor. We did a toString method. What else should we do? Equals and hash code. Just let it take care of it. Right? It's very complex code that it takes care of. It's ugly, but it gets the job done. It is based on everything in here. What else did we do over in person? toString, hashcode, equals, and compare to. So I'm going to ask you, should we do a compare to? Implements, comparable, book. Right. Let's go ahead and add that unimplemented method down here. And I'll ask you, here's a book and there's a book. How do you know that this book comes first and that book comes second? I mean, with a person, it was kind of obvious because you only had two pieces of data, right? But with a book, is it obvious? I mean, we've got a universally unique identifier in ISBNs. We could do that. Or we could do the Goodreads ID from their database. Or we could list it in alphabetical order according to title, right? Because we want to list all the books and we want to read them, right? We could list them by author. So Terry Pratchett wrote these 5 books, right? What's the newest book? What's the oldest book? What's the best book? What's the worst book? There's lots. My point here is that there are way too many options to narrow it down to one here. Instead, let's use comparators, okay? Like lambda functions over here in Python, okay? So I'm not going to do it in this class. In this class, I'm going to do it in this class, but not in this Java class. Right? Instead, I think that we've got a pretty good start. Now, just because I design my objects like this doesn't mean that I can't come back and change them later on. Like, oh, okay, well, now we've got a new piece of data that or it's not just a year anymore. It's a release date of a full date. Come back here and change this from an integer to a local date. You can always come back and refactor, but this is a good enough start that we can start processing some data. Right? So I'm going to create another class called bookutils.java. Not .java, but bookutils. I probably also want a main in this one. Right? So my goal here is to, 1, load up books from a CSV file. 2, produce some reports. Right? What is the best book? All right. What is the worst book? All right. What is the newest book? And finally, what are all the books by each author? Not just Pratchett. Right? So the exact same things that we did in Python. I'm probably going to want to use searching and sorting. I'm probably going to want to map them out so that Terry Pratchett maps to these 5 books that he wrote. Right? Instead of using a dictionary, I will be using a map in Java. All right, step 1, load up books from the CSV file. You know, I don't like doing stuff. I don't like implementing stuff. What I want is a list of books, right? Books, loaded up from a CSV file in, say, data, books, bookdata.csv, right? I want there to be a function. I really wish there was a function to do this for me, right? Or I wish there was a chunk of code that would do this for me. Anytime you find yourself wishing for something, grant your wish. Just put it into a function, right? Not load file, but load data from file. Right? That's too long. Just load data. Right? Okay? So let's write that function. Public static list of books. Right? Load data. And we're going to take a file path. Right? There we go. I'm going to put it to do for now. Load data, bookutils.load data. We need to import list, there we go, and to do implement. Right, right, just so that I don't forget. The reason I wanted to put it at to do here, and even though we're about to do it, is to show you the usage of these things. If you go down here to, where is it, tasks? There we go. All my to-dos are listed, including this one. Let's see, where's 156H? There it is. I think there it is. Double click on it and it takes you right there. All right, let's go ahead and close this. Again, double click and it opens the file and takes you right there. So if you've got a to-do list down here, right? I need to do some documentation on that. I need to do that. I need to do that. Make sure that you are documenting it with a to-do. Once you have done it, get rid of the to-do. That's cruft. All right? I'm not done yet though. All right. Let's get this first one done. Same steps as in any programming language. Open up the file, process it line by line, close the file. Right? But I do have a shortcut for you, I think. Don't I have a shortcut? Lines. Yep, there we go. Here we go. I think we did this in 155H, right? There we go. I'll walk you through after I've imported everything. Import. There we go. And I'm not going to hard code data.bar or data.bar.txt. There we go. And didn't you import as well? Okay, no you didn't. There we go. Import that. There we go. And let's rethrow this. Throw new runtime exception E. All right. So again, hopefully this is mostly a review. But what am I doing here, at least in the copy-pasted code? I want the contents of the file. All right? I can do that by doing this with a one-line. Oh, actually, I don't need both of these. I just need this one. Yeah, I want this one. There. There are all the lines of the file. Read all lines. Right? There's one liner. It's a one-liner there, and I don't need to print them out. Right? Just like Python. We did that in Python, right? We opened up the file. What is it? Read lines in Python. And then we close the file. This takes care of all that for me. Right? So there, I don't need this anymore either. Right? Actually, let's go ahead. Oh, yeah. System.out.println lines. So let's return null so that it compiles for now. Right? Actually, let's create a list immediately. List book. And call it result is equal to new array list. There we go. And let's go ahead and return that result. Bring that in as well. Import that. Right? And let's run it. File no such file exception. Right? There is no data book CSV file. Why? Well, do you see I see a data folder there, but do you see a book data.csv file? Nope. So let's create it. So new file, book data.csv, and come on. Didn't think you had to think that hard to just create a file, but you do, apparently. All right, while that's thinking, I'm going to grab, where is the data? I'm going to grab the data from over here. Oh, it was thinking because it immediately opened up in Excel. Thanks a lot. That's not what I wanted. Open with Adam, and there. All right. So you'll see this little icon here because it's .csv. It's automatically associated with Excel. It's a plain text file. Drag and drop it over into your editor, and you can play around with it like any other text file. Okay. All right. There's my data, exact same data that we were working with in Python. All right. All right. Let's see if this works now. At least runs. Right? So there's the first line. There's the second line, third line, et cetera, all the way to the end. There's the last line. Looks like Monstrous Regiment, Terry Pratchett, 2003. Was that in fact the last one? Yep, there it is. Okay. Now instead of printing it out, what I want to do is I want to process that. How did we do that in Python? Each line. No? So here's a line. Let me open up the file. Right? First of all, we skipped the first line, right? Right? But here's the second line. What kind of data is that? CSV data, right? So in Python, what did we do to chop that up into tokens? Remember? Split, right? Guess what it is in Java? Split, right? So for each line, ... after the first, ... split it into tokens, right? For each token, or actually not for each token, but create a book using an author and book using those tokens, ... So for each line after the first line, I'm going to use a traditional for loop here. For int I equals 0, I is less than lines.size, I++. But I'm not going to start out at the first line. I'm going to start out at the second one. Right? That's one way of doing it. The Pythonic way of doing it would have been what? For line in lines 1 all the way to the end, right? We could use that nice little syntax to skip the first line. Can't do that here. but we can get a subset. Lines is equal to lines dot sub list, starting from 1 all the way to the end. Lines dot size. See what I did there? A sublist, kind of like a substring. Right? I'm only going from 1 up to and including the last element. Is that right? That's inclusive, exclusive, probably. Inclusive and exclusive, so yes, this is what I want. Because if there are 5 things in there, 0, 1, 2, 3, 4, I want from 1 to 4. So 5 minus 1 gives me 4. Right? And now I don't need to use this traditional old for loop. I can use a regular old enhanced for loop. For a string, line in lines. That looks very Pythonic, doesn't it? Just a slightly different syntax. Instead of for line in lines, the explicit in keyword there, I'm using the colon instead. So for each line, split it into tokens. How do we do that? String tokens is equal to line.split. And we're going to split based on semicolons. All right? That does unfortunately return a regular old array. Why? Because it's old. Right? It predates lists and dynamic data structures. This function does. Right? All right, now I can create an author and a book based on those tokens. Again, the idea here of using the scratch is that you can always come back and look at it. Let me go ahead and bring it over here to our book utils and remind myself of what it looks like. Right? So tokens of 0 is the ID string. It's an integer, we decided, right? Is equal to tokens sub 0. But is that an integer? Tokens is what? A string. So remind me, how do I convert a string into an integer in Java? Integer.parseInt. Right? How do I do it in C? A to I, A to F. How do I do it in Python? Int float. Right? Tokens sub 0. There's the ID. What else do we want? Title. So string title is equal to tokens sub 1. Right? String, what's next? Last name, first name. So I'm just going to create a person immediately. Author is equal to new person. And I'm going to pass in tokens of 2 and tokens of 3. That's going to be the last name and the first name in that order. Remember that is indeed the order, last name, first name. I wish Java had named parameters. In other words, last name is equal to this, something like that. Like you can do that in Python. Then you wouldn't have to always, was it last name, first name, or was it first name, last name? You don't have that luxury over here in Java. You have to look it up. Right? Last name, first name. ISBN, which is a string, is going to be tokens of 4. And rating is going to be double.parseDouble, tokens of 5. And year, int year is equal to integer.parseInt, tokens of 6. There, I've got all my data now. And I can create a book. Book B is equal to new book, passing those things in, ID, title, author, ISBN, rating, year. There. Once I've got my book, I need to add it to my list. Result.add B. Let's run it and see if it works. Well, it does because it's not doing anything. So let's print them out. So sanity check, print the books out. Right? Normally this would be the poor man's way of debugging, but you do want reports, right? Let's go ahead and print them out. For book B in the collection books, system.out.println book B. I don't have to worry about anything else at this point for lines 48 through 49 because I already did the groundwork in designing this object. Remember that I've got a toString method. I've got a constructor, right? Everything over here was way easier because I did that groundwork and design first. And now this runs with no problem, right? The High Crusade, Paul Anderson, 1960, ... Right? Now, if I start to want to tweak things and I only want to 2 decimal places of accuracy, then you can always come back here and change that, right? I don't have to deal with hundreds of lines of code that would otherwise be in this one class. It's all separated out into proper classes now, right? Looks like everything was loaded up correctly, but I do want to come back here and be a little bit more defensive, right? So if you split the tokens and, for example, say that I've had a bunch of empty lines, is that valid data? Are you going to get 7 tokens on line 103 or 102? So what's going to end up happening? Exception, right? I can't split it. If tokens.length, if you have 7 of them, then process it as a book. If you don't have 7 of them, that means that you have bad data, ignore it. Or if you want to, you can throw your own exception. Else, throw a new runtime exception, bad data at line plus, what is my line? Line. All right, there we go. There. Now, bad data at line whatever. If you want to, you can add a counter, and you can say line 58 of that file. We can do that in 3 minutes, right? Close that, close that. Here's a counter, int counter equals 1, right? And then no matter what, we are counting, so counter plus plus. Let's do that at the end. Right. There we go. Bad at line number counter plus, and then a colon. And now you get something that looks like this, right? There. Oh, come on. Count plus counter, sorry. Bad data at line 101. Now I can go to my data file. Oh, what the hell was happening on line 101, right? Well, I'm off, my counter is off by 1. It meant 102, right? Let's go ahead and start at 0, I guess. No.
You should add it before the counter plus plus.
Oh, okay, we could do that too. I was just going to start it out at a different number, but yeah, it was originally right. There we go. There. Now something happened at line 102. And I printed it out. I don't know that I'm printed it out because I don't have nice formatting here, but you can escape that semicolon, that double quote, escape that double quote. There we go. There. Now I know that my line is empty and I can go check it at line 102 or something. Right? So I'm throwing my own exceptions here and I'm being a little bit more defensive. Right? Real quick preview of Friday. What are we going to do? Create a comparator. We're going to sort it by rating. We're going to sort it by newest or the year. We're going to sort it by author, and then we're going to use maps to get the rest of it done. Right? A note: as you're leaving, this isn't relevant for the live stream, so I'll go ahead and end it. Actually, no, there might be people watching. I don't know. Next week is the career fair. Right? Now, when you read bits and bytes, it's going to tell you to go Wednesday. Don't listen to that. Go Monday, Tuesday, Wednesday, and Thursday. Because, I think the Wednesday or whatever it is for computing. But guess what? The first one is education. The second one is like arts. The third one is computing in STEM. The fourth one is something else. All 4 days are relevant to computing, right? Because every single company, every single organization, schools, construction companies, etc., they need computing students. They need computing interns. My recommendation is to go every single day, right? Because every one of those is every company now in 2024 is a tech company. And they hire tech people. Even if they don't hire them as like primary developers, they still need IT. They still need somebody who can competently take something out of Excel and treat it like a CSV file, and the stupid process that has taken 5 people 50 hours a week is now all automated because of you. don't tell them it's automated, right? Say, oh yeah, this data entry stuff is really hard. As in the background, you're hitting a button to do it, right? And getting paid mad money for it, right? And yeah, don't tell them about it. Right. And then of course, the usual Reddit threads are also build in a delay, so that when you hit the button, it takes 5 seconds for each data to process, so that it looks like you're manually entering it, right? So all those little tricks, right? But again, every single day, there's going to be a company there. And even if there's not, who cares? Go there and talk to them. Low risk, practice your communication skills. I'm not going to go to this company, but they don't know that. Talk to the HR goons and say, what is your company like? Just get practice talking to somebody so that your nervousness goes away when you talk to the company that you do want to be hired at, right? So go as many days as you can. Also, there's free stuff, so you can grab as much free swag as you want, right? All right.